Let's talk about language for a moment. Things like this is a pencil. This is a dry erase marker. This is a dry erase eraser. Protons and electrons. I have a well, maybe I don't have a proton. Or electrons. Like, what are these things anyway? As human beings, we try to understand the world around us. I think that's kind of one of the awesome things about humanity is that we're curious and we want to know things and understand things. As human beings, we have limitations on what we can understand. Our language is both an expression of our limitations and perhaps forms the limitations, but nevertheless, language is kind of what we think about, and language is kind of like synonymous with thinking. I mean, I guess I don't know that for sure, but it certainly seems that way to me. So, as human beings, we put labels on things in attempts to understand them. And if something is not understandable, that doesn't mean we can't put a label on it. Protons, neutrons, and electrons. The protons and neutrons are in the middle, and the electrons go around the outside. There's 2 electrons in the first energy level, and there's 8 electrons in the second energy level, and there's 8 electrons, but there's a 4th energy level and a 5th energy level. The electrons can move from energy level to energy level, and when they do, they either emit or absorb electromagnetic radiation. In about 1900, the what of chemistry was pretty well in place. There were elements. The elements had different weights. Their properties were pretty well understood. Their combining ratios was pretty well understood. The what was pretty well lined up. In 1869, Mendeleev, a Russian scientist, lined up the elements by weight and realized that there were patterns in their behavior. The patterns were not absolutely consistent. There was 2 and then 8 and then 8 and then 18, but nevertheless there were patterns. And he came up with a periodic table which pretty much stands to this day. The first part of the century, like say about 1900, the what of chemistry was completely unknown. Niels Bohr, instead of saying, why can't we understand this? He said, let's take what we're observing, take it as fact, and move forward with that. He concluded that electrons were in stable energy levels, and that they had to be in certain places. And the whole field of quantum mechanics was born. The field of quantum mechanics is an abstract set of words to explain things, to explain observations. That's really the whole idea of quantum mechanics, is it is used to explain observations. And as human beings in the 21st century, we live in an abstract world in a very large way. We have computers and we play video games. We check our email, which is kind of an abstract kind of thing. We watch television, which is kind of an abstract sort of thing. And I think that the world of quantum mechanics as an abstract world is not that much of a stretch from our ordinary experience. And I think that if we take chemistry in general and quantum mechanics specifically and accept them as abstract representations of things that we really don't understand very well, I think it'll be easier to learn, I think it'll be easier to teach, and I think it'll be easier to remember.